Okay, ladies and gentlemen, let's go for Stats Day 2. We're going to start doing dot plots. Dot plots are a relatively simple way to organize data. Nothing more, nothing less. It's called a dot plot because we represent numbers, well, using dots. So let's take a look at this first one. It talks about test scores for Mrs. McGraw's math class, and it gives these. Now, the nice part, when we talked about 5-number summary on day 1, is that you were required to put them in order. Well, here's the nice thing about this. This is going to put it in order for you. You just have to follow along. So this one is nice. It's labeled. The number line is labeled for you. That's not always going to be the case. You're going to see a problem later on where you're going to have to label it yourself. And that's not going to be that big of a deal. You're just going to have to, like with any graph, label it how it's going to make sense for the problem. So let's start doing some math. Okay, so it says construct a dot plot to represent this data. Be sure to label the graph. Well, I'm going to start with labeling the graph. That's going to be fairly simple. And what we're going to do is we're going to put down here test scores. Okay. So that's the first thing that we're going to do. The second thing we're going to look at is we're going to look at our scale. As you can see, we have 1, 2, 3, 4, 5, and so it's 40 to 45. You have that. So each one of these tick marks here is 1. So example, this will be 41. The next one will be 42, and so forth. So please just keep that in mind. Now we can get into the actual construction of our dot plot. So that, we're going to start off, I'm going to go here. First number we get is 44. There's a 44 here. You could use a dot. You can use a little X like I did right there, or whatever you prefer. 44. 46 is next. 52. 49. 53. Now you notice we have 53 repeated. That's fine. I just put another little dot over it. That was a horrible dot. I don't understand what I did there. So I just put another little dot over it. Same thing here with 52. Just put another thing over it. 44. 52 again. 47. 54. 44 again. 53 and 52. Now we start getting down here. Remember these, don't miss those. I go 40, another 49, looks like another 47, another 54, another 47, a 45, oh, 55, and a 49, another 49. And ladies and gentlemen, look at that. Now this makes it easier for us to count things. It also is going to make it easy for you to find medians and things like that later on when we have you do those. So let's go through what this is going to be asking us. So first and foremost, it's asking us to find how many students scored over a 50 on the test. Well, that's easy. I go to where 50's at. Well, I don't have any 51s, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 students that scored 50 or higher. So 10 students. Make sure you include that label. How many students scored between a 48 and a 55? Well, here too. So 48 is here. If you notice, we don't have anything there, so that doesn't count. So really, all I have to do with this is just add to this. 1, 2, 3. I have nothing until then. So I have 3 plus the 10 I had before. So that's going to give me 13 students. fairly self-explanatory. Helps, like I said, helps us organize, helps us keep track of data. Now, range of scores. Again, highest minus lowest. Remember, range. So R equals highest minus lowest. So, the highest minus lowest, what's my highest number? The highest number in this instance is 55. That's the highest score. I'm subtracting 40, which is my lowest score down here. And that's going to give me 15. So that will be my range is 15. Okay? Again, it's pretty self-explanatory way of doing these things. All right. Next. Let's take a look at some of these other ones. Okay. And this is going to, again, we're going to be doing the same type of deal, but we're going to get to some different questions. So, number 2 says it ages at your first job. It gives you that data set. Okay, so we're going to go through. We're going to do this again. So I'm going to go 12, 22, 17, 13, 16, 17, 15, 13, 13 again, 13 again, and 13 again, 20, 15, 17, oh, here's an 18-year-old, 14, 15 again, 14, 17, 20, and 16. Okay, so the question is, the first one for part B is how many were under 16? Well, 16, that means we're under, so it's not saying they're at least 16. So basically it's saying this is X is less than 16. That does not include these. So we do not, in this question, want to use these. Okay? And I'm going to emphasize that in giant no with many exclamation points. No. So instead, I'm just going to count these guys here. So under 16, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those guys, those 11, we're going to have 11 people. Okay? So now this next question is how many people were at least 17. So at least 17 means that X is greater than or equal to 17. We're not having a graph of inequality, but that means that I do include 17-year-olds into this discussion. So these guys here, 1, 2, these guys here. So we have 1, 2, 3, 4, 5, 6, 7, 8 people. 8 people. Okay. So now this is pretty interesting, this next question. This is talking about distribution. So we haven't talked about this, but you have 3 options with distribution. You have what's called a skew right, a skew left, or normal. Now, the skews, and we'll get through this on a different worksheet as well, the skews are opposite of what you would think. Basically, for a skew right, so this would be a skew right. This is my SR. I have this. My curve will be like this. And when we actually put this over our thing, it'll make more sense. This one here is going to be my skew left. So it's down here. Notice the big hump is on the right. It's going like that. And then my normal curve, so this would be my normal. Well, that is your good old-fashioned bell curve. So the normal is a good old-fashioned bell curve. So, anyways, so what I'm going to do, I'm going to choose a completely different color than what's on that board. Let's go with pink, so because it's going to stand out. So I'm going to make a hump over most of my data. Boom, this is most of my data is. It's starting to go down. Ooh. And if you look where all this is. Most of this data is here on the left-hand side. So if you notice and you look at our pictures, that looks an awful lot like the skew right option. So that is the distribution. Now, if you guys are wondering why is that skewed right when all that data is towards the end? Well, the reason it's skewed right, because I know it's like all the data is on the left, it's these points here that are skewing the data. So these points drag the curve to the right. So those points drag the curve to the right. That's why it's called a skew right. That's why you might be looking at going, oh, what's on the left-hand side? It must be skewed left. Not the case. It was exactly the opposite of what you see. Normal, if it was normal, you'd see everything kind of in the middle. And hopefully we get to a problem like that. Okay? So, next, scroll on up. And if you have questions on that, please feel free to email me. Here it says the senator's assumed office. So it's got this guy, this nice little thing here. You got J. Rockefeller, all this good stuff. Now, here's one of these where it doesn't give you the numbers down below. So what you have to do is I'm going to take a look and see the range of my data. So I'm going to first and foremost with this, and this is a good one to go over. My lowest number here is Mr. Leahy here at 34. So Mr. Leahy is our youngest guy. Who's our oldest senator? That would be Heidi Heitkamp. Sounds German. Jawohl. So there you have a spread. So what I'm going to do, it says, what's the spread range of data? So I'm going to answer that question right away. Because what that's going to do is that is going to help me figure out how I'm going to label this graph. Okay, so the range of the data. So I have 57 minus 34. Oh, that's going to give me a big whopping 23. Let's see how many things we have here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I have 19 points to get 23 in. Now, I know what you're thinking, that you can just kind of label however you want. So there's a couple of things we could do here. One, you can count by twos. That's perfectly fine. The only thing is you will have to go in between, which that should be okay. Or you can add in what you need. That's also legal. You're not bound and regulated by what is on here. So if I'm going to start at 34, 35, this will be 36. Put that guy in 37. I can go 38. So that's 35 there. I'll go 39, 41, 42, 43, 44, 45. I know this is getting hard to read, guys. Sorry. I'll do this. I'll zoom it in for you. 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, and 56, and 57. So we added in a couple of lines. It's not ideal, but that is something that you can do if this isn't going to fit your needs. So we just did that. Okay? So now let's construct the plot, shall we? All right, so 34, we know we've got Leahy down here. Done. All right, so let's see what do we have? Mitch McConnell. Oh, he's still in office. Good for him. Maria Cantwell. I think she still is too. Now we have Mark Begich and Mark Pryor. Then we have Sherrod Brown. Mark Warner. We got Chris Murphy at 39. Jack Reed. Rockefeller. Cochran over here at 41. Patty Murphy at 42. Haidt Kemp, jawohl. That looks terrible. At 57. We got John Barrasso at 54. Tom Harkins at 45. I think Harkins is still around too. Okay. So here's another reason that I had you guys fill this in. If you just took the numbers that they had given you, you're not going to get an accurate reading as to the distribution. So, first things we're going to look at modes. Remember, mode, that's most often used. Okay, which one's the most often used? Let's look. Let's see, I have 42 is used 3 times. 47 is used twice. 54 is used 3 times as well. So 3 and 3. Okay. Cool. So what that means is I have 2 modes. 2 modes. I know you guys love when I write in cursive. So 42 and 54 are my 2 modes, each with 3. Okay. It says how many senators were older than 52. Again, this is greater than 52. Okay. To put in mathematical terms, so if there was a 52-year-old senator, we could not use them because they need to be older than that. Well, that's pretty simple. We just got 1, 2, 3, 4 over here. We already had these guys highlighted. 52 is here, so this would be the cutoff point. Right here would be my cutoff. That's 52. So everyone there would be 4 senators. And said, who is the oldest senator to take office? Again, that one's pretty simple. That's my max value, and that would be right here at Heidi Heitkamp. And you could just put Heitkamp. Okay. Now, there's one thing we forgot to do. And that, ladies and gentlemen, what we forgot to do is label the chart. So just remember, ages of senators. Okie dokie, folks. Good. All right. This, guys, this would actually be a pretty normal curve. So if we were going to do something like that, most of our data is in the middle here. So I would have something that looked like that in terms of our data. So this one would be a fairly normal distribution. That's kind of what it would look like. Yeah, I have 4 out there, but you're not going to have a double hump because most of our data, so I have 4 people out there, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 guys in there. That's the vast majority of our data is in between 39 and 47. So that is why it would be a normal range, because it's stuff in the middle. That's why I would prefer, and you probably should too, if you're given a chart like this, to fill numbers in if you have to, because that's going to give you a more accurate reading on the distribution. All right, next. Oh, we got height. We got the height of the Blackhawks team. All right. So, let's do this. So let's look. We got, let's see, what's my range? So first thing, again, what I want to do, I want to find my tallest guy and my shortest guy. My tallest guy appears to be 76 inches. My shortest guy appears to be 61. Again, that's my range. So I'm going to go 76 minus 61. That's going to give me 15. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. What's going on with that? Alright, so what I'm going to do is I'm going to go 61. But then I'm going to do this. I'm going to fill it in 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, and 76. Okay, now again, not ideal, but it's going to help you because when we talk about distribution and such. So create the dot plot. So I know that I have a thing at 61. So this is 61. Boom, right there. Next, I don't think I have anybody at 62. I'm going to cross him off. I do have somebody at 63. In fact, I have 2 guys at 63. Now let's keep moving. 64, I do have somebody. I don't have anybody at 65. Anybody at 66? I don't see anybody. 67, no. 68. Again, no. 69, the next guy. 70, boom, boom. 3, 4, 5. 5 guys that are 70 inches tall. Next, 71. Looks like just one guy. Alright, 72. I've got 1, 2, 3, 4, 5, 6, 7. 7 guys that are 72 inches. 5, 6, and 7. Okay, 73. I got 1, 2. I don't see anybody for 74. I see one dude at 75 and one dude at 76, and that's all my numbers. Okay. So again, I'm going to make my distribution. If you look at where most of my data is right here. This is definitely a skew left. Make sure you label the graph, guys. Height of Blackhawks players. So now they're asking me some other questions. They're asking me the mode. Okay, the mode. Most often. Most often is pretty easy. If you look, I have a lot here. The mode is 72. And then the next one asks how many people are at least 68 inches, so that we have x is greater than or equal to 68. So I'm going to make a hard cutoff there. Now I get to count. I have one. Oops. Not what I wanted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 guys, 18 players are over 68 inches. Okay. So, a couple of things. So we talked about the skew, so that's the distribution. If I were to ask you guys to find the median, so this is some bonus stuff that we're doing down here. You can definitely find the median and then the mean out of this deal. That's my X bar. So there's a lot of things that we're going to be able to do with the dot plots. The next thing eventually we're going to be doing is we're going to be combining this notes and the last notes that I created, where you're going to be required to create a 5-number summary off of it. So keep in mind, this is a very, very nice tool to have. As you can see, everything is pretty well organized. So how would I find a median off of this? Well, let me show you. So the median, I'm gonna go boom, 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 because everything's in order. I don't have to really worry about too much here. Boom, 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 boom. And then I have 71. I don't know if you guys can see this or not, but I have, I'm going to change the ink really quick. I have the 72 up here and the 71. So the median, I would have to average that. So I'm going to go 71 plus 72. And this is going to, and then I'm going to take that, I'm going to put it over 2. So that's going to end up being 71.5. So that would actually be my median. I don't know if you guys noticed that we had 2 in the middle. Okay, the mean, remember, I'm going to add up all those numbers. The first thing I want to figure out is how many there are. So as you see, 1, 2, 3, 4, 5, 10, 11, 18, 20, 21, 22. So I have 22. So whatever. So I'm going to add up all those numbers and then divide by 22. So let's do that. So we would end up going 61 plus 63 plus 63 plus 64, and you would go plus 69 plus 70 plus 70. This gets pretty repetitive, I know. That's 5. And then 72 plus 72 plus 72 plus 72. 1, 2, 3, 4, 5, 6. There goes 7. All right. And then that plus 73 plus 73 plus 75 and then plus 76. Okay. Let's find out what this all adds up to. Okay, so that ended up giving me this whole big shebang. Ended up giving me 1,542. Now I'm going to take that number, I'm going to divide that by 22. So my mean is going to be 70.1, it appears, or 0.9. So that's going to be my mean. So my x bar is going to equal that. Now, what you want, ideally, is for your median and your mean to be equal. In this instance, they're fairly similar. So this is a pretty good data set when your mean, and even though it's skewed, it's a pretty good data set if your mean and your median are pretty close. Like I said, it is skewed left because these points here drag the curve left. So now I'll even mark that. Where is it? This one. So these points drag the curve left. Okay. So that is the biggest thing. You have to remember, it is not where the data is at, it is where the curve is being dragged. So that is the thing, and that's kind of why I'm throwing all this stuff in here at you. So I'm going to put this online. You guys can watch at your leisure. And also, there is another practice sheet for you guys to do with some similar data. If you have questions, like I said, please feel free to email me. I will hope to hear some questions. All right, guys, bear with me with this e-learning stuff. This is Mr. Files over